So this is our lipid signature assignment. Our mystery snack was 2C7.
The goal of this study is to develop and evaluate isolation and separation of methods that best supports a mass-based quantification of lipids in snack foods. Our assigned snack food was 2C7, which was a salty, oily potato chip that appeared to be a Lay's original chip.
Our proposal for the isolation outline was first we would grind up and weigh our 1 gram sample of the assigned snack food, put the sample in a centrifuge tube and add 2 to 3 milliliters of methanol and shake vigorously. Then add 2 milliliters of cyclohexane and shake again. Put the centrifuge tube in the centrifuge machine for 3 minutes. Weigh a 20 milliliter beaker and record its weight. Remove the liquid lipid layer and weigh the sample. Place the beaker on a hot plate and turn to low heat. Evaporate the sample until just the lipids remain. Weigh the beaker again after evaporation. Subtract the weight of the empty beaker from the final weight of the lipid sample to find the weight of the isolated sample. Repeat this procedure for the acidic water and cyclohexane.
So for our group procedure, what we did first is we got a centrifuge tube and add 4 milliliters of acidic water and 4 milliliters of cyclohexane into it using a pipette. We then took a sample of our assigned food, which is also appeared to be a Lay's chip. We crushed it into a fine powder using mortar and pestle. We weighed 1 gram of the assigned food sample. We placed into the tube along with the cyclohexane acidic water. We placed the tube in centrifuge and centrifuged it for 3 minutes. After we used the pipette to extract the top layer of the centrifuge liquid and separate into 3 separate layers. We then took this top layer, put it onto a beaker, which we then put the beaker onto a hot plate and boiled until heat setting 3 until the liquid stopped boiling. We then weighed the fat in the beaker and divided the mass of the fat by the mass of the assigned food. We then repeated these steps 1 through 7 3 more times to get multiple.
So these are the equations that we made to validate our procedure. So this is for the control test. This is for the control test. We did the mass of the remaining lipids in grams over the original mass of the fat in grams multiplied by 100 to equal the percent fat. And below is what our mass was. So it was 2 grams over 2.21 grams times 100, and it made 90.49%. So this validates our procedure because we use the same equation like the one above to calculate the percent fat in our snack food in our control test. By getting such a high percent in our fat in our control test means that our solution to separate the fat is accurate.
So for group B, for our control, we took a known amount of lipid, 2.05 grams, and we put it into a solution of cyclohexane and acidic water. We did our whole procedure, boiled out to get our lipid alone, and we got a mass of 1.78 grams of lipid, and we divided that by our original mass, which was 2.05 grams, multiplied by 100 and got 86.82%, which was our percent lipids. And since we have a pretty high percentage yield of fat, we can validate that our test is pretty accurate for getting the highest amount of lipid.
So this is group A's iodine test. First, we separated both solutions into 2 1-drum vials, tested the lipid solution by diluting it with an organic solvent, and then add the iodine test. We put a single drop of the iodine test solution into each vial. Observe if one of the 1-drum vials containing the solution turns yellow and orange or black and blue. If the solution turns blue and black, it contains starch. If the organic solution contains starch, there would be a small drops of black liquid at the bottom. If you are using an organic liquid like oil, the indicator may not work well.
And then for our protein test, our validation, so we took remaining substance that was in the beakers after the heating plate and added 2 milliliters of cyclohexane and then a drop of the iodine solution. Then we added 2 milliliters of the NaCl to the solution to see if there are any remaining proteins. If the solution was not viscous, there were no proteins. In our solution, there was no viscosity, so which means.
So for group B, we also did an iodine test and a protein test. So for our iodine test, we basically just took the samples straight off the fat samples off the hot plate, and after measuring the mass, after doing that, we just added a drop of iodine into each 2 samples. And then we waited for like a few seconds to see if the sample turned black or blue. And if it turned black or blue, this indicated that starches were present in the sample. And if it failed to do so, and it turned an orange or yellow color, this meant that the starches were not present in the experiment. We did this for all of our trials, and all of the samples did not turn black or blue, which indicated that starches were not present. For the protein test, we basically did an extra trial, but instead of extracting the top layer of our centrifuge to liquid into the separate beaker, we basically put it into a 1 gram vial, and we added 4 milliliters of saturated NaCl solution, otherwise known as salt water, into the vial with the cyclohexane lipid solution. We then mixed it, let it settle, and we determined that if the NaCl solution was foggy, that meant the proteins were present, and if it was not, the protein was absent. This was due to the NaCl will bond to any protein molecules, and all of our protein test, it was not foggy, which indicated that protein was absent.
So this is our Group A's results from implementing Proposal 2. So for the assigned snack food 2C7, we found the mass of the 2C7, the mass of the isolated lipid in grams, the percent fat by weight, and the average percent fat by weight. For the control test, we found the mass of the control test in grams, the mass of the lipid isolated in grams, and the percent fat by weight. And you can find all these calculations in later slides.
So this is our iodine and protein validation test results and outcomes. So you can see on the 3 left images, that is our iodine test results. So we have methanol, salt water, and acidic water, and you can see that all of the 3 beakers have an orange-like substance, which indicate that there is an absence of starch.
And then on the right, you can see our protein test, and because it's orangish pinkish, that means that there was no protein left.
So for Group B results, we had similar result, or we had the same general things. We have the mass of our original chip, the mass of the lipid present, the percent fat by weight, and the average fat percentage. And then our control group, we have the known fat, how much fat we rendered, and the percent fat by weight. And then for our iodine test, we did it individually for every single one of our experiments, and they all came back negative for starch because they all turned orange. And for our protein validation, we only carried it out twice since our process was similar up to this point. So we concluded that we did not need to run it for every individual trial.
So these are our Group A calculations. So our first calculation is the percent fat by weight for the assigned snack food. And so that was just the mass of the remaining liquids in grams over the mass of the original snack in grams, multiplied by 100 to get the percent fat, and below is the mass and the numbers that we got. And then the second bullet point is percent fat by weight of control test equation. And it's pretty much the same thing, just the mass of remaining lipids in grams over the original mass of fat in grams multiplied by 100 to get the percent fat. And then the last equation is the average percent fat by weight. And we just took the 3% of our trials, added them, and then divided by 3, and we got the average percent fat.
So far, we did the same, pretty much the same steps as Group A. So for percent fat, we just took the amount of fat left, the amount of lipids left over from our experiment, and we divided that by the mass of the snack food sample that we initially crushed and put into the cyclohexane acidic water mixture. And after we did that, we got around 50%. We multiplied that 100% to get on 50%. For the percent fat of our control test, we basically did the same thing. We divided that by the mass of by the amount of lipids, about the mass of the fat inside of our control test that we already knew. And we got about 86.8%. And for our average percent weight by fat, we took all 3 trials, divided by the number, we added up the percent fat of the snack food, divided that by the number of trials, and we got about 13.5% fat, percent fat.
So this is our comparison of Group A and Group B. Overall, between both groups A and B, we had different results. Each of us used different waters. So personally for Group A, we used methanol, but Group B used acidic water. And our similarities were we ran the same tests, but we just got different percents based on the different solvents.
So recommendations to improve the analysis for group A was making sure our volumes are correct, being careful to make sure we don't spill any of our liquids, and then weighing our substances to the exact grams.
So for group B, we basically said that we should round each decimal place to for every step and or just don't round at all. We also tried to extract the top layer we should probably extract top layer with a bit more finesse. We didn't end up extracting some of the bottom layers. We should also boil each of the lipid solutions in a similar size container so that the boiling is like more like consistent.
And then for the reflection, we just learned that through experimentation, we were able to find what which solution works best for their fat. And then we were able to conclude which solution works best through our control test. And then through experimentation, we were able to create procedure that we can use for other experiments to create new procedures and solve problems.
And then for group B, we overall learned that this experiment helps improve planning because there's a lot of steps and possible solutions that could have been attained. So narrowing down the options was essential for constructing an accurate test. And then the knowledge from this lab can be transferred onto other labs, as well as real life applications such as complex recipes or something along those lines.
Yeah. Okay.
Well, let me just check.
I don't know. They do a little. It's some of the. Really fast.
Yeah.